Hello everybody, and welcome to a new tutorial from Organian's Puzzlebox. In today's video, I'm going to show you how to create the best possible decal material using Parallax Occlusion Mapping. This video will go in depth on fixing some of the most common problems with Parallax Occlusion Mapping and decals in general. We're going to talk about a feature to mask the angle of a decal so that it doesn't kind of go and stretch across multiple surfaces. We're also going to fix the parallax occlusion mapping viewing angle when a decal or a parallax occlusion texture is on a vertical wall rather than a horizontal plane. We're also going to be talking about how to fix shadows so they show up properly and they actually are controllable, how we're going to fix our, in general, the look and feel and performance of parallax occlusion mapping when used with decals. So this video is kind of a, how should I say, it's your one-stop solution, I think. But if you do want to kind of skip over all of this and, basically support the channel, feel free to have a look at my project called the Decal Forge, which comes with a very powerful tool to create decals for your environment. It already has all of these fixes in there, plus many, many more features. But it's in that Decal Forge project is also part of the Surface Forge project if you want to have a look at a plugin that allows you to paint surfaces in Unreal Engine, much like what you do in Substance Painter or Photoshop. So yeah, feel free. But without further ado, let's start the tutorial. Oh, and before I forget, the material shader in the blueprint will be available to download from my Patreon page for free, so that you have a shortcut and something to follow along if you want to. But, I'll leave it to you to decide. So I'm going to do the project in here, and effectively we're trying to reach the default decal, which is here. We're trying to make it look like the Decal Forge over here. That's effectively what we're trying to achieve. So this is using a very basic decal setup here. There is nothing fancy about it. We just have a base color and normal and some roughness and ambient occlusion texturing going on. While the Decal Forge, obviously this decal has shadows and depth and everything else, and it also works nicely on a vertical wall and on a horizontal plane as well. So if we actually have a look at our default decal, if I go over here and I want to have kind of similar features to the Decal Forge, then I could just go over here and enable the Parallax Occlusion Mapping, which is now going to add depth. And then I can also enable Contact Shadows, which is going to add shadows, which it did. But obviously these shadows are extremely heavy, thick, and so on, because we're not using any particular special settings for them. We're just using the default sort of settings that come with the Unreal Engine decal material. Meanwhile, the Decal Forge works quite nicely, but once we set up everything we need to set up, it will look a lot better. If we actually go over to the ground plane over here, right, we'll notice that there's actually quite a lot of slicing. So if I actually disable the contact shadows, we'll be able to see all of the slices, the slice planes that the Parallax Occlusion Mapping is using to create that depth on the decal. Now, we can increase the minimum steps, and as you can see, it's decreasing those steps. They're still visible though. And we can actually, we've got the max steps that we could increase this like to 124 maybe. And we have the minimum steps set to 32, or maybe we can do 64. And now the steps are virtually gone. But this also comes at a very large performance cost. The Decal Forge doesn't really have any kind of stepping, and it's actually using a different kind of algorithm to resolve the step issue. And we're going to go into how we set up this material so that you can benefit from the same performance gain and also look. Another problem with the decal from the standard decal that comes with Unreal Engine is that when we move the camera left to right, I'm not sure if YouTube is showing this properly, but we are kind of getting quite a bit of warping on the height of the texture. While with the Decal Forge, we don't get any of that warping. It's actually very stable and it's not blurry, while this one gets blurry and it's also unstable. If we look at the wall, this is how a standard Unreal Engine decal looks like with the standard Parallax Occlusion Mapping node. It's just simply unable to use parallax on a vertical surface like this, while this material over here for the Decal Forge is perfectly fine. And we're also going to go into the fix for that as well in this tutorial. gonna open here the material. This is the normal code for parallax, for a standard non-POM. I know it's written here POM. It's actually non-POM setup for a decal. All we have is some tiling, 3 textures, and then they're just connected into the base shader, and that's it. That's basically the standard setup. Now, if you want parallax occlusion mapping, then the only thing that you're really doing is you're adding a parallax occlusion mapping node. So you can actually just type in here parallax occlusion mapping and you'll see it. When we have a look in here for this, we just need to set up the height. So we're going to have to use a height texture. Now, usually this is, for example, we could take this texture sample from over here. For me, my textures contain the height information in the blue channel. But when we feed them over into a parallax occlusion mapping node, you have to feed in a texture object. So if you convert this to a texture object, you don't have the option to split the components here. You could go over here and type in split components, but you'll notice that it doesn't show up because split components does not work with a 2D texture object. It only works with a texture sample. So if you go to RGB here and you look for split components, you'll have that. So you can then separate RGB. But because of this, parallax occlusion mapping has a different kind of technique. The texture object just connects over into here where it says height map texture to 2D, just like it does over here. And what we're doing is we're using a constant 4. So just simply hold 4 and left click anywhere on the canvas, and then you'll get this constant 4. And what we're doing is we're connecting the RGB alpha to the height map channel over here. And we are ensuring that the color is set to blue, or whichever channel contains your height information. So if it was on the red channel, then you'd have 1 there and 0 here, right? And that will ensure that the parallax occlusion mapping node is reading the height from the blue channel. But we're not doing that. We're doing it from the blue channel, like I've said, not from the red channel. So then we also connect a parameter to minimum steps for the parallax occlusion mapping, a maximum step, and then we have tiling, which is going to the UV, the height channel that I told you about, and then the reference plane, which just dictates where is the parallax occlusion mapping going to be using its steps to increase and decrease the height of what you're feeding inside the surface of the parallax occlusion, either being a decal or just a simple texture on the ground. But basically that reference plane is like we're using 0.5 as a default value because that's the midpoint where we want our texture to be used, the height texture to be used to increase or sink the effect. The outputs are a parallax UV, which connects to the UV of each of the textures that you're feeding into the main shader. And then you also have a shadow, in case you're using shadows. This output connects into a multiply that multiplies with the base color inside here. This is a very bare bone method of doing it, but it gets the point across to create shadows. And then this is the shadow code. So what you do is you connect this to shadow, so you put that in there, and then this directional light, which has to be multiplied by -1 in order to be inverted, you connect this over into the light vector, so then the parallax occlusion mapping shader knows where the directional light is coming from. And then you have the parallax occlusion shadow steps. So you put them in there so your shadow looks better or worse depending on how many steps you use. And that's basically how you get shadows, but you could also have a shadow penumbra parameter set up so that you can control the shadow strength or how more light it gets. And this is the setup that I'm using entirely right now, where I've got all the parameters set and doing some switches so I can disable or enable parallax occlusion or contact shadows. So again, it's very basic, but it's the same thing as what I showed you up here, which just some switches, right? That's it. But now we want to look at starting to upgrade this. And the first, there's going to be, I'm going to set this up in such a way that it kind of deals with the first problem all the way to the last problem, which is like making it look nicer, right? So first of all, we've got to fix some of the fundamental issues before we proceed. One very important thing that I want to show you is the performance cost of our current parallax occlusion mapping and how we can improve it. So if you go over into our main shader, by the way, just make sure that your shader is deferred decal set to translucent, otherwise it won't work. So when you make a new shader, that is. So what I've done is I've added into the emissive color slot in here, I've connected the material complexity steps debug over into a multiply node and to the performance measure and put that into the emissive color. With that done, and if I go into my, over here into my material instance, I will be able to now turn this performance measure up or down. So here's the thing, if you actually set this to 0.5, let's say, or 0.2 or something like that, this will light up the decal and it will show you just how expensive it is. Now, if it's completely white like that, it means that it's, you know, extremely expensive. And if it starts to get a bit of a color, right, like, you know, towards green, then that means that its performance is increased. Now, the thing is, when you look at it from, you know, up here like that, head on, it's actually going to be the lowest performance cost because it's not calculating as much as opposed to your point of view to create all those steps in order to give the illusion of depth. So if we actually turn these steps down to something more manageable, let's say like maybe like an 8 and then a maximum of 16, which are kind of where you want to sit if you want to have this material to look quite nice. You can see in there just kind of what the, you know, right now it's quite performant as a shader, and when you go and you look from the side, you can see that it starts to get a bit more red where it's trying to calculate all this depth. But we're using quite a low amount of steps, and if we disable that performance measure and put it to 0, you'll notice that this looks very bad. And especially if you have this on a wall and a character walks past, then that's very visible and very ugly indeed. So we need to fix this by fixing the steps, and I have a solution for this which I am sure that you will appreciate. So over here where we calculate our steps, we need to add a brand new calculation that's going to do all of our steps for us. So what I want to do is I'm going to take the POM max steps. I'm going to leave this, by the way, the minimum steps. I'm going to leave it to a default value of 4 for now. But I'm going to take my POM max steps and I'm going to add a lerp node over here like that. And then I'm going to add a second lerp node over here. Now I also want to add a saturate node as well. So the node that's going to make all the difference to all this is going to be a dither temporal AA. The result will go in the saturate node so that we can actually get this to be clamped between 0 to 1. And then this will connect into the alpha of both of these lerp nodes. The reason why we're doing 2 lerp nodes is because we're trying to like hit 2 birds with 1 stone. And I'll show you what I mean in just a second. This max step node will connect to the A value over here of the lerp node, like that, right? And this one we're going to put this over to like a number of 64. So you could do lower, but I'm going to leave it to 64 for now. And in the second lerp, we're just going to clamp it between 22 and 18. So 18 being the minimum value and 22 being the highest value, right? And then I'm going to add over here a texture parameter, and we're going to call it dither random amount or something like that. It doesn't really matter. And then this will go into the random noise like that, and the alpha threshold will remain as is. We don't need to change it. So what we're going to do is this lerp node is going to connect into our max steps, and then this other lerp node will connect into our shadow steps. So we've done both shadows and the POM max steps in one go. Then we're going to hit apply and go back to our material in here and pull out the material instance. Okay, now we're going to do the performance metric again to 0.2. And this time I'm not touching anything in relation to the steps. I don't actually need to. You can see the noise when you enable emission. You can kind of see where all the steps are, but I'm going to put the performance measure to 0. So I want you to tell me, can you see the same slicing as you saw before? Probably not. And the material is quite performant. But look, we can actually increase our max steps or decrease them. And you'll notice that the difference in quality doesn't take that much of a hit. So we can go minimum steps. Now this is really bad, right? But we can increase our max steps, which is up to 32, which is obviously lower than what it was before when we were trying to reach max level. And then we can also do the min steps a little bit, but I would recommend min steps to 4 and max steps to something like 8 or maybe 16 if you want to look a bit better, right? But performance metric wise, at this level of quality, is going to be quite in the green most of the time, and especially if you look for up like that. But if you go down here, it's obviously we're going to get a bit of pink and red all over, but the quality of the material now from viewed from an angle is far superior than what it was when we were using the other method. So we can obviously push this down to like an 8, right? And the quality of the steps is still pretty good, even though our performance is probably you know, twice as good as what it was, right? But you can always play around with these settings until you get the right value and the right performance ratio. So that's kind of how you fix the performance of steps on parallax occlusion mapping. I think it's quite a nice, neat little trick that will definitely improve your, as I said, overall your performance. Also, one thing not to forget, because I kind of forgot to tell you, the dither random amount, which I've written wrongly here in the parameter, you do have to set this up to a value higher than 0. So try 1, 2, 5. Don't try very large numbers, because once you go into very large numbers, it will just, the fine grain of the actual dither will not be visible anymore, and the steps will start to show up again. So you want just a value of roughly around 3.6 is going to be just fine for this particular effect. Next step in our setup is to actually adjust the height of our parallax occlusion mapping, because we're not really able to do that right now. If we go over here into the node, you'll see that we're not using the height ratio for anything, but by default it's using a 0.08 value. Now, I don't like to just plug in a scalar parameter in here called height ratio, because normally that's just not the right way to do this. We want to have a let's call it a physical accurate method of dealing with height based on our viewing angle. So for that, I've created a setup of nodes that's going to work perfectly for this. So we're going to put our height ratio over here, and the first thing I'm going to get is a world position node, and we're going to use the X, Y, and Z data from here for us to work with. We're going to leave this to absolute world position, including material shaded offsets, and from the X, Y, and Z, we're going to type in a DDY node, and then we're going to also bring a DDX node like this, just so we can actually ensure that we're physically correct on calculating this height. We're going to calculate a cross product between these two, like that, right? And then we want to normalize this calculation, and we're going to feed this into another into a dot product node. So let me just search for that. And in the B value over here, we need to invert our camera vector. So I'm going to search for a camera vector world space, and we're going to, as I said, multiply that by a -1. So we're just trying to invert that. This is the correct way to invert, by the way. So if you want to invert anything in shader language, this is kind of how you do it. Right, so we've got those put together. Then I want to saturate this value to make sure that it's always sticking between 0 and 1. Just don't use a clamp here, just use saturate, because you're never going to change between above a value of 1. Just stick to 0 to 1. And then we want to add a control point. So we're going to put our power node here, and this is where the height ratio will then connect. So the exponent of the power node is going to be to 1. We're going to add a multiply node just so we can connect our height ratio. And then all of this connects over into the height ratio of the parallax occlusion mapping node. If I actually hit it right, there we go. I'm going to press apply, then going to go back in here. And right now we have a height ratio of 0. So if we play around with this value, you'll notice that we can control the height either upwards or downwards, so we can go in reverse or down. So by default, I'm going to put this to maybe like a 0.2, something like that, which should give us what the value was of 0.8 earlier. Now you may want to toy around with this setting depending on how good your displacement texture is for your parallax occlusion effect, right? But it can be a 0.1 or 0.2. Now one of the main reasons why we did it this way is because of our solution to fix this issue on a vertical wall, which you will see in just a little bit. Now we're going to deal with our shadows. So by default, we're just putting in a sky atmosphere light direction into a minus multiply node and into the light vector. But that's not going to help with the shadows to look nice, because right now, if we actually just enable shadows, so if we go over into over here and we just enable these shadows and we have a look over how it looks like in the world, this shadow looks pitch black, and it's honestly not looking very good in the crevices. Like if you look at the Decal Forge one, the shadows have detail in them and they actually react quite nicely to light, but this one is just all over the place. It just simply doesn't function correctly. It will react to light, but it will react to light very awkwardly and very badly. Okay, so we need to fix this. The best thing for us right now in order to fix this is to go over into where we have that light vector and start adding a few more nodes. Going to delete this POM shadow steps because we're using a different one. This shadow penumbra can stay where it is. It's not really a problem. It's these nodes here that we need to toy around with. So the first thing that we want to do in order to fix this, we're going to add a pixel normal WS over here, and we're also going to add a vertex normal WVS. Now, this is a solution that fixes both the POM decal shadow, but also for a normal texture added onto a static mesh. So this works for both solutions here. So this is why I'm doing all this, just so it covers both problems, okay? Now, we're going to use this as a base node for everything. So I'm just going to add a dot product node here, and this multiply will connect to the B value and the pixel normal offset to the A value. And we do need to use a 1 minus node, not to be confused with an inversion node. This functions differently than just doing a multiply by -1. And I want to take our shadow from here, this shadow, what I call in here the shadow blend, okay? So it's a name reroute. I'm going to search for that, shadow blend, or you could just drag the pin from here if you want. And this shadow blend will go into a subtract node. So what we're doing is we're going to subtract from our shadow blend. We're going to subtract this 1 minus node that we just created here. And then we're going to push this into a saturate node again to climb between 0 to 1. And we do want to divide this value. So we're going to type in divide here. Want to divide it by 2, okay? So this is going to give us the, we're going to do a new name reroute in here just for simplicity's sake. And we're going to call this, just for you to understand where we're going to put this, we're going to call it basically, oh, I keep forgetting the name, specular. Yeah, so we're going to call this like a specular mask blend, right? Specular shadow blend. So we know that this will link into the specular part of this issue, because specular is currently affecting our shadows. And then this one, the vertex normal WS, we're going to duplicate this dot node over here so we can put our multiply over into the A value like that. And then we want to get the vertex normal VS into the B value. We want to feed this into a power node. And this is going to be called shadow normal fade, okay? And this is going to have a default value of, let's say, about 0.8, and we're going to put that into the exponent of the power node in here. Now we want to add a add node. I want to use the shadow blend that we made from the Parallax Occlusion Mapping, and we're going to connect them over like that. Okay, and now we want a lerp node in here, and this add node will connect to the alpha of the lerp node. And now we want to have a value here of 1, which is the this is going to basically say that whatever B is shown, that's the color of our texture, and whatever the A value is, that's going to be our shadow. So we want to either create intensity or decrease intensity. So the alpha decides, this alpha decides where the shadow is showing up. This B value here decides where the texture, our normal texture, shows up. And the A value decides where the shadow shows up and how intense it is. Because, I mean, the alpha will divide the color from the shadow, but this A value here will dictate this how powerful the shadow is. So we're going to add the new static parameter, and we're going to call this shadow intensity. And we can have this to a default value of, let's say, about 0.3. And this will connect to the A value here. And this will go into another name reroute called shadow map, like that. Okay, so we have one for specular and one for the base color. Going to hit apply, and now we need to add them in here. Okay, so in order to add them quite quickly, we can do a multiply over here and another multiply like that. Now for specular, we can do a very simple thing where the specular is just simply a value that we're adding in without much thought or reason. So what I mean by this is, this multiply node can connect to the specular to 0.5 there. So now it's going to be between 0 and 1. Over into the A value or the B value, doesn't really matter. We're going to search for our specular shadow blend, and we can put that into the A value. And then we're going to do a scalar parameter, and we're going to call this specular intensity. Okay, and this we're going to keep it to 0 for now. Going to put that into the B value, so that's done. Now the base color here, this one, which is in this static switch, is fine. We can pull this over into the A value, And in the B value, we are going to search for our shadow map, okay, which is the node that we created down here. And then I'm going to plug this into the base color and hit apply. So one thing to see over here with this decal, I want to show you why we did the shadow blend for specular. So I've just put the plane over here so we have sunlight hitting the surface. And if we go over into the material again and we, for example, untick this specular and we apply the default value of 0.5, you'll notice that all of our shadow areas are now also using specular, which is kind of breaking the effect of shadows. I mean, they look extremely terrible now. It just looks like we have maybe some coal or something in there, or use the marker pen or something on it, right? So what we want to do is, this is why we're connecting this over to our specular intensity. So this is masking the specular everywhere where the shadow hits, apart from the surface where we could see it. So for example, right now, if we go to specular intensity, if we put this to like 100 or something, the specular only shines on the surface that's visible to the directional light and not where the shadow is happening. This is not very visible on this kind of texture, but trust me, this is basically what we've just done. Now this shadow here can be decreased by using the shadow intensity slider. By either, if you decrease it, it will make it worse, or the shadow more intense, and if you decrease it, it will make it lighter. Now I noticed that we're kind of having a glitch because the shadow is not actually showing any detail in here, and that's because within here, within the shader node, I forgot to remove this bit. So I'm just going to remove the shadow blend and shadow and this multiply node that we had here, and instead I want to bring these two nodes. I'm going to cut these and bring them over here like that. And these are the nodes that I need to blend with now because I've created this entire new setup. So just going to connect this multiply like that. So all this switch is doing is basically disabling shadows in case we're not using parallax occlusion mapping, so we can save on performance. Now I'm going to press apply, and if we go back into our material, now you'll notice that if we if we decrease the shadow intensity, it will become a lot darker, and if we increase it, it will become a lot lighter to the point where it disappears. Now you don't want to go above a value of 1, because going above a value of 1 means that you're going to add extra brightness into the shadow areas, and that's not something that you want unless this is something that you're going for, like this effect, right? But going to the value of 0 means that the shadow is pitch black, and just increasing this value will lift those blacks a little bit so you can get some details in those crevices. So now the shadow looks a lot more natural. Now bear in mind, this is only self-shadowing. This shadow only works on the surface of the decal parallax occlusion mapping, or the texture that you're using it on a, if you're using on a static mesh, but it will not work to cast shadows from these bricks onto this plane over here. So let me just move these back into the original position where we were earlier, just so we can kind of see our effect here again. There we go, something like that. Okay, so now we're back in the shadow. We've obviously created the shadow that we wanted, and it works just fine. Again, here, because we're also getting this shadow from this area, you may want to lift that even further to get a bit more detail. But again, this is where I'm putting it to about 0.3, which I found works just nicely. So now we need to go to the next bit, which is, well, fixing this problem. So for us to fix this problem, we need to modify the parallax occlusion mapping node. You will find this parallax occlusion mapping node if you click on this, magnifying glass over here. It's actually in the engine functions, so you don't want to modify that, but instead you want to copy it. So I would go to window and create a new content browser folder in here, right? And I have already copied one here, but I'm just going to delete it to do it again. What we want to do is control space to bring that content browser where we found the parallax occlusion mapping, and you want to drag and drop it over here and copy it. So now you have one into your project. We're going to rename this to maybe say something like tutorial, okay? And once we have that, we can change it. So we can drag and drop this one into our material shader to replace the default parallax occlusion mapping with this new one that we just copied, because we're going to modify this and we don't want to modify the default one to break something, you know what I mean? So let's just do this one. Okay, now you can double click to open it, right? And I'm going to drag it over here. There's virtually no difference between this one and the default one, but we are going to modify how the camera vector is being handled inside the parallax occlusion mapping node. This is going to allow us to use a blueprint to basically tell our parallax occlusion mapping where our decal is situated on what surface and how to project the depth of the decal or the parallax, sorry, properly in conjunction to our camera vector. So we're going to pass that information through a blueprint, and this is going to be quite easy, but it will be substantially better than what we currently have. So let me just click apply here. I haven't made a modification, but I will do now. What we're going to do is we're going to plug this camera vector into a new calculation. First of all, we're going to remove the transform vector from world space to tangent space. Just bear in mind where it connects into this false here on the switch. So I'm going to then search for inverse transform matrix like this. And then I'm going to put the camera vector into the vector to transform and the transform vector over here. Now we need to set up the function inputs for these three axes. So we can actually right click and promote to parameter, but this will create just a constant for value, not a function input. But what you instead want to do is you want to search for a function input, and then we can plug this in there. And we do need to name it, for example, basis X or something like that. And then you need to do this for every one of these bases, for X, Y, and Z. And you also want to use the preview value as default. So this is the node. You want to do this 3 times. Now, I've actually created these 3 already. So I'm just going to delete them and actually rename this one over here like that. And all I need to do now is just plug them in there in order to get our calculation properly going. Once this is done, you can just click apply, and you're done with the parallax occlusion map node changes. That's everything that you need to do. We can now go back into our normal shader and continue from there. So inside the shader, we are going to create a constant for, but we can right click this basis X, for example, and just say promote a parameter, which will automatically create this, which is a constant for. It will also name it for us, right? And we want to leave it to a default value of 0, 0, 0 to everything. And that's then connected. We want to do the same thing for this one as well. And then we want to do the same thing for the Z-axis as well. Once we do all of this, we do need to actually use a component mask. So I'm going to bring in a component mask, and we're trying to mask everything. Well, we're trying to keep the red, green, and blue, but no alpha, right? So I'm just going to duplicate this 3 times. So we have these masks, and then I can plug them in like that. And obviously, the X mask will go into X, the Y mask will go into Y, and the Z mask will go into Z, like that. Now we can press apply. And if we go back into our decal in here, you'll see that some modifications have happened. Now the entire decal is looking black. This is not good, but we can fix this, no problem. What I mean by this is, if you open this material instance of the decal and you have a look, if we go over here where we have these colors, right? In order for us to bring that decal back, you basically need to start adding some colors like this, right? And now the decals are brought back, but as you can see, there are errors. So for example, we no longer have the decal display as 3D. It looks quite odd. It's kind of like all going into that direction. It's all showing in that direction. And if we go over here to the vertical, you can see that it's all going kind of to the right side down, right? But as you can see, we now have this warp instead of the warp that we had previously, if you remember, before we made this modification. But this is where doing the blueprint comes into play, because if we transform this decal into a blueprint that's loading up the decal, then we will have fixed this problem and aligned our height to our camera vector, and it's being calculated properly and more efficiently than what it was before. So we can start creating our decal blueprint by right-clicking, going over to blueprint and selecting a blueprint class in here. And we just want to do it of actor. So we're going to call this BP decal like that. We're going to double click it in order to open it. We're going to go into our construction script because over here we want to set the decal material. So the first thing you want to do here in the variables, just add a material instance, basically, because we want to be able to set the material instance of the decal. So I'm just going to type in material instance in order to find what I'm looking for. So just like that, and then we're just going to do object reference. Okay, so we want to set that, and in order for us to do it, we first need to create a dynamic material instance. So we're just going to type in create dynamic material instance, like so. And over in there, we want to add the material that we've created for this tutorial, which is this one here. So I'm just going to actually search for it, this one, tutorial decal. I'm going to put that in there, and now it's going to add the this material is going to be added to our decal. Now, right now, we don't have a decal, we just have a default scene root. So I'm going to add a decal, and this is the decal that we are going to set the material instance to. We then want to do set material instance. So we can click that, right? And then we take this return value and put it in there like that. You could also alt left click and drag this out in order to get it, and then you can just set it, right? But we are going to do it this way. Once you do it, you can then put set decal material like that, and it says there set decal material. It's got decal in the in the parenthesis, and that's because it's sampling this decal that we just created. And now it's saying, well, this is a new decal material, so that's fine. We can put the material instance in there like that, okay? And then we can press compile. Now, what we can do is we can drag the new decal that we just created, this one here. So as you can see, it's already loading the material properly, as it should, because it's just loading that decal material onto the decal that we've created. And now we want to go back into our blueprint in here, and we want to create a sort of like a parallax occlusion camera rotator. So for us really to do this, we can just do it here in the construction script, or it doesn't really matter. But as I said, it's fine to just do it as a function. So what we're going to do first is we want to take this material instance. So we're just going to put it in here, right? And we want to set the vector, set vector parameter value. Now, if it doesn't show up when you drag and drop, just type in set vector parameter value like that, okay? And it should allow you to connect this. But if it doesn't, it says in here, material instance object reference is not compatible with material parameter collection object reference. And this is a bit of a problem because you kind of always get this problem, like you're not really searching for a collection. But if you want to take context sensitive here, we should be able to get set vector. So I'm just going to do set vector parameter value, and I'm not looking for a material collection. I'm looking for the other one, which is this one. And now that's very odd. Object is not compatible. Oh, I think I know what I've done here. Yeah, this material instance should have been dynamic. So I'm just going to type in material instance dynamic. And we're going to change the variable type. And now we can connect it. See that this works now? Yeah, that's the mistake right there. Okay, so we have this set vector parameter value in here. We can do this after we've done the set decal material. That's fine. Okay, so we can connect it like that. And what this set vector parameter value is going to change is this basis. So we're going to take this one, right? It's going to change the x value one. So we're going to put it like that. We're not going to put anything into the value yet. We do want to duplicate this about 3 times more after this, so we can just connect it like that. And then this material instance can connect the rest of the targets like so. So this is done in that particular regard. We now have the material instance set up in here. We need the values now. So what we want to do is just drag the decal from here. Just make sure you don't drag this one from component, but you drag this one from over here. And then from it, go and get owner. Make sure that you have context sensitive on so you get the right get owner. Otherwise, you might get the wrong one. Okay, once you do that, now we can get the actor transform like that. And over in here, we have these, this return value. We can actually split the structure pin, and this will give us the return value rotation, which is what we want to, we want to sample the rotation of the decal in world space. So with that done, we can actually break break rot into axis. So now we get 3 axes to work with, X, Y, and Z. And as you can probably see where this is going, we're going to take each of these and we're going to plug them into our axes in here. So we want to take the Z and we want to connect it over into this value for the, sorry, not the Y one. I think I've got Y2. Yeah, I do have Y every time. So let me just go back into here. We have X that I want to copy. So I'm going to put X into here. And then I've got Y already, and I'm going to take the Z one. Just make sure you copy the material name so you don't mistake when don't make a mistake when you type them in. So now I can connect this, the Z axis. I want to connect this to the X value. And then I've got the Y axis can go over into the Y as it was, like that. And then the X axis is going to go into the Z value. Okay, so in essence, they're basically inverted. And then I'm going to press compile. Well, they're swapped, they're not inverted. And now I'm going to go over here and have a look at my parallax occlusion effect just to see if it works properly. The best thing for us right now is actually to take this surface and bring it up into the world so we get a bit more light, maybe something like that. And let's have a look if the parallax occlusion mapping is working appropriately. So right now, it's still got a bit of an issue, so let's fix that straight away. So as you can see, it's not, I mean, it is updating as we move around the camera. It's following us, but it's following us in the wrong direction. It should move away from us, not towards us. So this is where you go over here into these transforms. So let's just make sure that we tidy them up a little bit so we can see which ones is the first, which one is the last, and so on. Okay, so for the first one over here, the Z one, we want to multiply. So we do a multiply, and over here it says, we want to transform this. We don't want this to be a vector, so we want to promote this to an integer. So we're going to multiply by 1 here, right? And this is going to go, as I said to you before, this is going to go over into this conversion. So converts the vector to linear color. So this is where want to connect that. Then we can actually duplicate this node again, and we're going to do the same thing for X. So instead for X, which is going over here, instead of doing a 1, we're going to do a -1. So we're trying to make this look away from us like that. And then we want to copy another one for the Y value here, and this is going to be a positive value, not a negative one. So we can connect it like this. And then we can press compile, and let's have a look if this is now working okay. And it is. It is actually facing away from us, showing us the depth as we want to see it. So you can see now that it's kind of come together. This is literally what we were trying to achieve. The look of the decal forge, but onto just a parallax occlusion map decal surface without running more complicated code. So now that's all coming together. Let's go further down into our well, actually I don't even actually need to go down there, but yeah, let's go down there for argument's sake, because I want to show you the next final fix that we're going to do in this video. So when you look at our decals over here, you can see the decal forge does not blend, or it does not show up onto this surface. And if I actually go into its settings over here for angle fall off and I decrease this, you'll notice that it's now is able to actually climb up on that surface, right? But this will mean some bad stretching. As you can see over there, it's not looking correctly. Okay, so let me just take the decal forge away because it's already got the fix that we need. But our current decal, which is this one that we've created in this tutorial, does not have this fix. As you can see, it's currently showing up on two surfaces, and there's no real way to control that. So we need to be able to fix this issue using an angle fade kind of calculation that's going to effectively fix this problem for us. And it's not a complicated fix, by the way. This is actually quite a simple thing that we can do to effectively create an angle mask. So we're going to go back into our material over here, and this is where we're going to use the opacity, right? This is going to be one of those things that goes into the opacity of the decal, and this is why decals and using translucent material means that it's using the opacity node. So we want to bring in the world position in here, and then what we want to do is use the X, Y, and Z. Actually, I'm going to copy this code right here, right? All of this code all the way to the saturate and the power, like that. Okay. I'm going to copy this entire node structure from here, and I am going to paste it over here like that. We do need the world position. I'm not sure why I didn't manage to copy that, but anyway, going to plug these like that. Okay, but over here in the dot product, we need to get the object orientation so that we know in what direction our decal is orientating to in world space. So we're going to put that over there into the dot product, and into the power over here we need to do a decal angle fall off like that, and this is going to have maybe a default value of 1. I'm going to plug this over into power, and then this is going to go into opacity. Then I'm going to press apply. I'm going to go back into my level in here. Okay, and now we need to get that now we need to get that control, right? So the material instance control, wherever I have placed it. So let me just go over here. There we go. We found it. This is the material shader. So I can go into the decal angle fall off, and you can see in here, right, as I increase this number maybe to 10, it is now completely faded that surface problem that we had there, like that. So here we have it in a far more visible scenario where I think, you can obviously see exactly how it's functioning. So if we take this to 0, you can kind of see how it's blending with this surface. But if you push it up, then it just disappears. And this is a very, very nice way of dealing with this problem. And you can see here, if we're rotating it to something like 50, now we have it showing up on this surface over here instead of that surface. Obviously, most of this process is a lot easier and more straightforward with the Decal Forge blueprint, but this is just kind of how you can upgrade your shader for a decal parallax occlusion mapping without going through the headache of, getting my project, I guess. But yeah, that's kind of all I wanted to show in this video. I will be making up I'll make a follow-up video with some more improvements, but I hope you enjoy this. So that was it. I know it was a bit of a lengthy tutorial, but the thing is, there's a lot to show and a lot to explain. I don't want you to kind of leave this tutorial without proper knowledge and understanding why we did what we did. I know there are some things that I haven't really touched on, like what's the math behind some of this stuff, but ultimately I don't want to make 2-3 hours long videos. But with that said, I want to thank you for for watching it, my viewers in general, my Patreons who make everything possible, YouTube members, Gumroad members, and the people who've purchased my projects on Fab. Thank you once again, and if you want to support the channel further, have a look at the Decal Forge or Surface Forge, and I'll see you guys in the next video. Keep creating.